Also really cool to see the interest, people who care about how it's oriented. It was nice to see that it wasn't like falling on deaf ears like it has previously when we've said that. So all of that said, I should restate a few things here. There's one comment that said, but he didn't show the correct way to mount it. So we did. We had title cards in the bottom left of the video. I verbally said it when we got to the start of the experiment. The first one I showed, I said this is how you should have it. But to go over it again, because there were a lot of people who were like, well, but is this one correct, or is this slight different configuration that you're talking about it correct? Things like that. So first of all, if your cooler is installed against the recommended use, it's not going to just explode overnight. It's not like the pump, the plastic's just melting down every second you're sitting there thinking about if you should flip it over or not. You can calm down and take a few minutes. If it's inconvenient for you to flip it over today or this week or this month, that's fine. Put it on your to-do list and do it next month. It's not going to explode overnight, most likely. That stated too, the biggest thing, again, that we said in the video is that the radiator at the bottom, pump up top, or well, really pump at the top of any loop. You can do it front mounted, pump up top too. That is the dangerous one. That's the one that's going to cause immediate damage to the system. Not necessarily the impeller or the pump in a technical sense, but that's what people end up calling dead. They call the pump dead, even if it's magnetic levitation, doesn't need lubricate in the loop. But that's where you'll experience some sort of system failure or just really bad thermals creeping up over time. And even then, we're talking a time span of, there's no real like hard data that's out there publicly about it. We have some information from the suppliers, but it's sort of like increasing VSOC, the SoC voltage on a Ryzen CPU. If you increase it to 1.4, we know it's going to degrade the silicon quality over time, like the IMC, and reduce the maximum frequency minimum voltage you can sustain with whatever you're working on, memory for this example. So we know that's going to happen, but we don't have a hard timeline on when, just that it is a fact of doing that. Maybe it's 6 months, and commonly that's sort of the cited number for that example specifically. For these, if you install pump at the top, you might be talking, depending on the manufacturer, the generation of pump they're using, there's so many variables here, but you might be talking, say, 1 to 3 years of life rather than 5 or 6 plus, if it's installed that way, because over time, that air will work its way into the pump plate, and even if you're filled to, say, 98%, like Asetek's target, rather than 90, which is one of the other suppliers' targets, you're still going to have air up there, and it's still going to cause efficiency problems. It's still going to increase the temperature of that housing where the plastic can only really sustain 60 degrees internal temperature. So over time, if you're losing efficiency on getting heat away from the CPU, what's it heating up? Well, if it's not heating up water, it's heating up plastic, and that's bad. So again, the biggest thing is don't put the pump on the top of the loop if you can avoid it. If you have to do it, like it's some weird, like it's a Fantex shift or something, there's not a lot of great solutions for that case, unless you can maybe get it on the sidewall or I guess flip it over or something. Not really sure that's the best idea either. So in that instance, maybe just live with it and roll the dice. You might come out fine. It might survive past the usable life of the system. Maybe it'll be limping along the way in the end, but it might be okay. We would strongly recommend not installing it that way for just about every reason. But if it's literally the only option and you already own the stuff, unless you have a good way to move the radiator around, there's no reason to feel anxiety over it if you can't do anything about it at this point. So you just let it go, and if it dies, then replace it. No big deal. It's maybe, if it takes 1 to 3 years, sure, you feel like you wasted money when it should have lasted 5, 6 plus, but it's probably not going to take any components out with it. It's just going to stop circulating water, and you'll have downclocking and things like that. CPUs are pretty good at protecting themselves. The point of all that is to try and reduce the panic level a bit. Again, pumps at the top, I would immediately change it if possible. But if I can't change it, I'm not going to go buy like a new case and a new cooler for that reason only. Next one, away from the issue of cooler death, which is definitely at some point going to happen sooner in most configurations of the pump at the top of the loop, but not always. Just it is a bit of a roll of the dice, depending on how long you're using it, how high it was filled, and what sort of temperatures you're putting through that loop. But that's mostly guaranteed to be a bad thing. Unlike that though, tubes at the top, radiator at the front of your case, with the pump somewhere in the middle, this is a really common configuration. Like we said, the tubes often aren't long enough, so that's how it goes. This is primarily and foremost an acoustics issue, where anytime you hear like that bubbling noise, sometimes you'll hear a brief pump whine. That's often caused because of this. So this is all a recap in the video. You can skip to the next one if you got all this the first time. So that doesn't mean it's going to die as fast as the pump at the top, radiator on the bottom. That's not at all what we were saying. We're saying it's mostly acoustic first. It is performance at some level, and you might experience accelerated permeation, but it's nothing anywhere near as bad as rad bottom, pump at the top of the loop. So if you absolutely cannot rotate the thing, then again, don't freak out about it. It's just you might be dealing with more noise throughout the life of the cooler. It will get worse as the cooler ages if you're going to use the system for a long time, and maybe you replace it a year, maybe 2 years earlier if you're going to use it for 5, 6 plus. But it's not as bad as the much shorter lifespan of the other configuration. As far as sources, other than the testing we've done and the experiment we showed, we did speak with several companies on and off record for their representation. So officially we spoke with Arctics, one of their PMs, I think is his position. We spoke with Cooler Master, we spoke with Asetek in an official capacity, and then there were a couple of others that I'm not going to name or at least assign specifics of the conversations to, because in those other instances, I went to engineers at the companies and bypassed PR, which is generally frowned upon because the engineers aren't supposed to talk to media without supervision because they might say things that are bad for the company. So I can't name everyone, but I can at least give you big names that are important. Asetek, Arctic, and Cooler Master are certainly huge in the space. So all of them told us that they recommend against a bottom mount radiator pump up top, as seen in a lot of the ITX cases out there. This isn't us just saying, look, there's not enough water in the pump. You can see it in our experiment. It's companies that sell millions of these units who have RMA numbers, who have long-term thermal cycling testing, things like that. They're the ones saying don't install it this way. And in some cases, like EVGA, for example, has documents, and so does Cooler Master, where they explicitly strike through that orientation or the orientation like tubes at the top and pump above that. Corsair actually also in its manuals will recommend tubes at the bottom of the radiator when it's front mounted or side mounted, as the case may be. So yeah, all of them were quick to condemn pump top, and most of them were quick to strongly recommend getting the tubes at the bottom when it's in a front mounted orientation, but they weren't saying, it's like as bad as the other. One of the weirdest or maybe least informed comments we saw was something to the extent of like, well, but do you really think engineers would design something to be used this way if it's not going to work? The answer is, in a sense, yes. It's sort of begging the question, but it's not necessarily the engineers, because the engineers aren't taking those marketing photos. So this specific comment is relating to the NZXT and other product manufacturer images where they show their case with the cooler mounted in a way which is considered to be suboptimal and incorrect in many instances. So we see this fallacy a lot. It's really sort of frustrating to see where people say, well, but the engineers, they know what they're doing. One, they might not. They're not like infallible magic people. The engineers in this industry, there's some really good ones and there's some new ones. But two, it's really not about the engineers. They probably know. The ones we spoke with at the companies I just named, they certainly know. They were so happy to get in on this content. They were like, yes, please make this content. So many people tell us about their pumps making noise from being tubes up, and people tell us about have RMAs because they put the pump at the top of the loop. So both of these things are things that cause us problems and cause us RMAs. Please tell the world, here's paragraphs of information. So it's not that engineers don't know, it's that marketing and 3D artists who are making the renders, they're the ones taking the photos. They're not making the product. So it's not about, well, but Steve, don't you trust the engineers? I might, depending on who it is, but do I trust marketing to show the product and use properly? So it comes down to communication things with the companies internally. Besides, if an engineer wrote the marketing materials for these products, they'd be filled with the asterisks of like, well, technically we can't say it's the best because there is better stuff out there, but in a practical sense, we're within plus or minus X degrees and we can handle Y degrees per watt and our thermal resistance is XYZ. That's what you get with engineers. So anyway, in general, the manufacturers with whom we spoke recommended against the tube's top, radiator front configuration, pump in the middle, because the air bubbles will get sucked through the barbs and hit the pump, create noise, acoustic issues, and over time, as your water level drops, it will in fact bring more air through the loop. You can experience accelerated permeation to a small degree, not as bad as some of the other configs we talked about, and you will likely experience some form of long-term performance fall off, long-term acoustic issues, and depending on the pump and the cooler, obviously, it depends on whose product you're using, and potentially even early failure of the unit if it's one that doesn't have quite as much water when it starts life and it's run under a thermally abusive scenario 24/7. We gave all of these examples in the first video. Finally, for this one topic, this question, there were a lot of people who sent us tweets of like their O11 dynamics, things like that, where they've got it oriented in one of the many ways we already described, except the radiator's on the side of the case instead of the front. So the cooler doesn't know whether it's front mounted or side mounted. It just knows, in a sense, where the pump's located, where the tanks are located. So if you're asking, well, okay, but mine's like this, is that okay? If we said, and we did, this is okay, then, and it's hard to see here because of the length of that rad, but pump's in the middle. If we said this is okay, pump in the middle, tube's bottom, then also this is okay. Just to make that really clear, we had a lot of questions about that. So it's the same thing, it's just rotated 90 degrees. All right, now that I've remade that entire video, let's move on to the next point. Stop pestering YouTubers. Often, YouTube reviews feature systems that are built for maybe a day or less. And as we said in the first video, we don't blame YouTubers or PC builders on subreddits and forums for orienting their coolers one way or another. This is an education issue that's largely falls on the shoulders of manufacturers and making sure that they properly document how to use their products in the optimal sense, and then they say whether it's okay to use it in XYZ suboptimal senses, but they should be offering, and this is optimal use guideline, which is what we showed in that video, tube's bottom, if it's front mounted, stuff like that. So the reason I brought this one up is because I tried to preempt this and prevent it in the first video by really early on saying like, this isn't like going after YouTubers, but people still, I don't know what it is. It's some weird psychological thing where they're like, I've learned a new thing. I need to go show someone else how smart I am and how they're wrong or something like that. So if you're on YouTube and you see someone post a video of like a system build and the radiator's in the front and the tube's right at the top, you don't need to like raid them about orientation of the cooler. So that wasn't really the intent of the topic. Next one, does it matter where tubes exit the pump block? This is a good question. I didn't make any comments on this in the video and probably should have, just to clarify, but some people said, you know, the pump block on the CPU, mine has the tubes coming out of the top of it, but yours, they're coming out of the side. Does that matter? The answer is no. So orientation of everything, all those considerations are the same, but that doesn't really matter now. Next one, hot air rising and thermals of front versus top mounts. So this question was, quote, is there any disadvantage with hot air rising when mounting a radiator to the top of the case? There's a difference when you mount the radiators in different places of the case, but again, the radiator doesn't know what the front or the top is. What matters is the fan orientation. We'll get into that in a second. I want to address the hot air rising thing first. Hot air does indeed rise. But when you're talking about multiple 1,000 or 1,500 RPM or 200,000 RPM fans in a case, in a computer, plus whatever's on your GPU and your CPU, it doesn't matter that hot air rises because nothing's going to happen faster in that system than the air moving it forcefully. So hot air rising in a computer in the sense of DIY enthusiast, like the type of stuff we all work with, it's basically irrelevant if you have fans in there anyway. Maybe a really slight difference at the top of the case if you could conduct some scientific, heavily controlled test, and then definitely a slight difference if the top of the case is completely just like ensconced in metal and glass and things like that. But for the most part, if there's holes in it somewhere, hot air rising becomes irrelevant as you start planting fans everywhere in the system. So that's not the reason there might be a disadvantage. If you top mount, this is the best way to think about it. If your radiator's in the front of the case and the fans are in front of the radiator, then those fans have access to room ambient temperature air. Let's say room ambient is about 21 degrees Celsius. So what is that, like 70 degrees Fahrenheit or something like that. So now you take that system and you move it to the inside of the case where the air has been heated as it's come off of VRMs, come out of the video card, out of its fin stack, and scattered into the case. So now you might have a case ambient temperature where instead of 21, you're talking maybe 30 degrees Celsius for the air that's hitting the fan. So your baseline for the air going into the radiator is now higher. You cannot get below the temperature of the air going through the radiator. If the air going through the radiator is 30, your floor for water temperature is going to be 30. Probably plus a little bit too, because you've got some heat in the loop from at least the pump, if not the thing it's cooling. And if it's at the front, your floor is 21. So idle floor is going to be lower, and then probably the load floor is going to be lower if it's mounted in the front. Now, that said, this is actually completely irrelevant if you change where the intake is, because this is under the assumption that when you top mount, you're doing exhaust. You can top mount and do intake too, and then just be mindful of what your front fans are doing. Maybe you set them up to exhaust. It's not really ideal because in a lot of cases, well, it could be ideal, it depends on the case, but in a lot of cases, that means you're now pushing air through your dust filter on the front. Dust filter on the front's not really doing anything anymore, and into the room, which it's all going into the room anyway. The computer's literally just a space heater. That's all it is. It does a little bit, but pretty much everything turns into heat, so for the most part. So the difference is that it's coming out of the front, might be hitting you, it might be uncomfortable. So if your radiator's in the top and it's intake, it really, for the most part, it's going to be about the same as if it's in the front and it's intake, because it's just access to cold air that matters. Maybe your radiator body temperature is like a degree higher from proximity to the VRMs, but that's the answer to that one. Yes, it will be warmer if it's top mounted and exhaust in most instances. Does that matter? Well, not really. A couple degrees isn't going to make a world of difference. What will make a world of difference, though, is like acoustic annoyances from being improperly mounted in the front, and potentially longevity to a lesser degree than if it's pump at the top of the loop to really drive that point in, but potentially longevity, definitely acoustics, stuff like that. So the only reason you should care about a couple degrees is if you're chasing higher overclocks and it's your threshold for the highest single core delta, core-to-core delta is the highest core is, you know, that extra couple degrees would bring you down below TJ max. Okay, that pretty much recaps the main questions. There was one that was something like, but how is it wrong if you can install it that way? That was a really strange question. It basically said, this is where I was talking about we're getting a mainstream viewer base for that video. The question was something to the extent, I don't think I saved it, but I can fit it that way, so how is it wrong? I mean, you know, I can fit an AMD CPU into an Intel socket, and I can close the lid and everything for the most part, but it's still wrong. So that. Just because you can install something a certain way doesn't mean that it should be installed that way. But anyway, hopefully that addresses all the questions. I'm sorry to recap so much of the content. I know I repeated a lot of things. I know that's annoying to our regular viewers, but we hit such a wide audience on this last one that I was looking at the viewer retention graph, and you can tell where we're hitting that mainstream audience because it's a lot lower after the maybe 8-9 minute mark than it typically is, but the views are way higher. And then there's this huge spike at the end for the conclusion that we don't normally see quite to that degree. So this tells me that there's a lot of people in there, and it's evidenced by the comments I saw that I didn't include this, where they're like, what's the short version for those of us with the shorter attention span? Was almost word for word one of the comments. And, that's just, that's fine, but it's not really the audience I cater to. So in that sense, this video won't help, will it? Anyway, that's it for this one. At least they can jump to well, we had timestamps in the last one too, so I don't know. I've compounded my problem instead of fixing it. That's it for this one. Subscribe for more as always. If you want the Patreon episode, you can go to patreon.com/gamersnexus to get that, or store.gamersnexus.net to pick up a mod mat, a mouse mat, or similar items. The medium mod mats are in stock and shipping now, as are the wireframe mouse mats. Thanks for watching. Subscribe for more. We'll see you all next time.
Oh, it's like smoking.
Really?
Tempered glass, cold plates.
So before any manufacturers get any ideas from our contraption, we made this not because we want to see tempered glass RGB cold plate liquid coolers, but because we want everyone to stop doing it wrong. There's a lot of pictures from manufacturers of radiators and AIOs front mounted in cases with the tubes at the top. Or we've seen builds by people where the radiator is mounted at the bottom with the pump at the top of the loop in a closed loop system. This is a very bad idea. It's going to be bad either acoustically in the very least, with pump whine and gurgling noises and things like that, or in the worst case, it's bad because it potentially shortens the life of the cooling product that you've used, and you end up RMAing it when it otherwise would not have needed it and would have been totally fine if it had been installed correctly. So it's a bit irresponsible of the component manufacturers to show things mismounted, but we're going to correct that today. Before that, this video is brought to you by Thermal Grizzly's Conductonaut liquid metal. Conductonaut is what we've used in all of our liquid metal and D-lid thermal tests, capable of dropping CPU thermals significantly when replacing the stock thermal interface. Lower CPU thermals don't just allow better overclocks, but also lower noise levels because the transfer efficiency is increased. The mix of gallium and indium makes for a thermal conductivity of 73 watts per meter Kelvin, outclassing traditional pastes significantly. Learn more at the link in the description below. All right, so recapping the issue then, this has been something we've kind of noted on and off in reviews for a long time now, but most recently in case reviews over the last 6 months or so, we've noted that closed loop liquid cooling products should generally be mounted with tubes at the bottom if they're front mounted, although this isn't quite as bad as mounting the radiator at the bottom with the pump at the top. And these are both suboptimal at best to damaging at worst configurations for an all-in-one cooler, and it's what causes probably one of the highest reasons for RMA with liquid cooling manufacturers. Now, case manufacturers are particularly to blame for showing the products installed incorrectly, and since they are actually selling a product to people and providing recommendations on how to assemble it, it's particularly irresponsible to show coolers installed incorrectly on manufacturer websites. We've also seen just various system builders online, on forums, YouTubers, people like that, installing radiators in a way which is, again, maximally damaging to the product, minimally acoustically annoying, causing RMAs because people think that their pump's whining, their pump's loud, they think liquid coolers are always loud, they think pumps are always loud because it's actually just been installed incorrectly. And we don't really blame the YouTubers as much for that, and this obviously everyone will know now. It's more about blaming the manufacturers for sort of setting that undertone to begin with, that it was okay to install these radiators in a certain way. So this isn't going after anyone in particular, although maybe the manufacturers for posting those images on their websites showing coolers installed incorrectly. Okay, so what we've done is we've cut up a radiator. We're going to be using this as a test vehicle to show you how the water actually flows inside of the loop, because since saying it in case reviews for the last 6 months hasn't been good enough, we thought we'd actually just cut one of these open and show you how it works. To recap the problem briefly, we originally wanted to make this content piece because about maybe 8 months ago on the Patreon Discord, I received a message from someone who, one of our backers on there, who said, "Hey Steve, I bought this cooler that you thought was pretty good, but I have this pump whine issue. I was wondering, do you have that problem too?" And so I messaged back and forth with him. I got a photo of the system, and I said, try flipping the radiator over and get the tubes at the bottom of the case if you have enough tube length to get to the CPU still. And so the user did that and then came back to me a day later and said, thanks so much, the problem's solved, it doesn't make any noise anymore. And so we've been through this process with a couple of other people in one-on-one scenarios in the Patreon Discord over the past year or so, and almost always flipping the cooler the correct way around fixes the problem. Why manufacturers aren't more forward with this being the recommended installation is beyond me, but Arctic, as an example, is starting to revamp its manuals to include specific documentation on not just best use in terms of product survivability, which they've already got, but best use in terms of human factors, noise, things like that. So we took an older closed loop liquid cooler that we no longer needed. We drained it, and then we took a Dremel tool to each side of the tank. We should probably pause here to define the parts of a liquid cooler, because this is something we did previously in an animated video and it might prove helpful. Water enters the radiator from one of the barbs. Typically, this is after going through the cold plate's microfins atop the CPU. Some pumps are located in the radiator, but we're not talking about those today. We're only talking about the pump and block installations. The water goes through a barb that's tightened with a piano wire internally, and then it enters the tank. The tank is split about 40-60 or so for inbound and outbound water. The inbound water flows down the tubes, which are narrow but very tall, and it maintains a higher flow. Once it hits the other tank and turns around to return, flow slows down, something we'll talk about later. The fins contacting the tubes are responsible for spreading heat across as much of the surface area as can be crammed in without causing excessive flow impedance to the attached fan, which dissipates said heat. When the water routes back to the other tank where it enters the barb, positioned about halfway down the tank, it continues on to the CPU cooler's pump housing, pump, and microfins. We'll talk more about how pumps work in a moment, because that's another important part to the damage people are causing by improperly mounting radiators. Back to our experiment. We took the Dremel to the tank wall, which is made out of aluminum, and cut in a rectangular viewing port on each side. They're not clean cuts, but that's because we weren't exactly sure how deep the barbs would protrude into the tank, so we repositioned a few times. Turns out that the barb terminates almost exactly where the tank starts, making this easy. Each window is isolated in the middle by a dividing wall, which splits the inbound from the outbound water and separates it. We next took a drive to buy some acrylic, super glue, and a super glue curing accelerant. The accelerant chemically bonds with the super glue to rapidly dry it, generally in under 10 seconds. It's also a watertight seal for at least this experiment. After one failed attempt where we smudged up the plexiglass, we tried again and got a good mount to the radiator tank with the window. We then applied glue to the entire exterior of the glass to securely seal it from leaks. There's still some aluminum debris in the radiator from our cuts we made, but just know that that wasn't in there when we started. That's from our hack job of cutting it open. We next removed the cold plate and hastily cut a piece of acrylic for a viewing port. The goal of this window will be to view how the pump can run dry when mounted with the tubes up and the radiator mounted down at the bottom, like in the NR200P, for example, or with the pump at the top of the loop and with the radiator in the front, or the radiator in the front with the tubes at the top and the pump in the middle of the loop. It'll also show how the pump works, which makes for really cool footage. We kept the gasket to keep flow guidance, but obviously removed the jet plate and the cold plate for visibility into the system. This was again sealed with glue, although we discovered some flaws in this old design where it could leak from under the pump plate. We glued that as well. There are two really important points behind the science of liquid coolers that we need to get to before getting into the experiment. Obviously, we'd get 2 or 3 times the amount of views if we just started with the experiment and made a 4-minute long video, but our goal is to hopefully answer this once and for all so no one has questions anymore and this nonsense stops and people stop killing their coolers prematurely or mounting them in the bottom of the NR200P. So the first point is that liquid coolers have air. They will also develop more of an air gap over time as permeation takes place and that air pocket increases. But even shipping from the factory, they're going to have air in them. We asked manufacturers, three specific liquid cooling manufacturers and their suppliers. There's 2 suppliers in here. Those are the people who actually engineer and manufacture these things, and the manufacturers are the ones who set the specs. And the average distribution of liquid to air volume is between 10 to 2% air, with the rest being liquid, a propylene glycol mixture. So we can't name the 2 suppliers explicitly we got this particular information from, but it's the 2 largest suppliers in the space. One of them noted that they have a 2% air target for their closed loop liquid coolers. The other one said 10%. The reasoning for that is 1, manufacturing challenges, significant ones, and 2 is allowing some room for expansion and for preventing a burst of a weak seal in the event of a higher pressure scenario from running at higher temperatures, especially high liquid temperatures. As for the manufacturing side of things, we've actually been to cooler factories and can show how that works. After all the assembly processes are complete and the radiator is sourced from a supplier and connected with the loop, the cooler is taken to an infusion machine where it is vacuum sealed for a couple of seconds, making the loop airtight. The machine then relies on the natural physics of air pressure to suck liquid into the cooler and its radiator from an external tank that's filled with said coolant. Instead of filling it forcefully, pressure is used to pull the liquid into the tanks. Cooler Masters Factories is one of the highest end that we've been to for this, and it uses a simple button press to pressure check multiple times against the volume to ensure it's within safe operating parameters to prevent leaks. That means leaving some air as a buffer. But there's some left anyway when disconnecting all the hoses, the infusion machine, and the vacuum seal. Another manufacturer told us that its coolers typically have about 1 cubic centimeter of air in stock conditions for the average cooler. One supplier further told us that it has a loop, which is actually 100% filled with liquid for a laptop product, but that this significantly increases cost and it is not feasible for mass market single unit discrete coolers. As for permeation, that's dependent on a few things, mostly the temperature of the water in the loop, the materials used in the loop, and the length of the tubing in the loop. Things like clear acrylic or clear plastic are much more permeable than working with something like EPDM or something like that for your materials. And we'll talk about the material engineering in a few moments. So over time, your loop will slowly lose water volume to permeation. It's going to, you'll end up with a lower volume level if you could see into the tank like you can through ours that we've made here. And most manufacturers currently spec for a life of at least 5 years of ideal operation, with potentially some life beyond that in suboptimal operation. Many units do live beyond this, like some of the ones we've had here running for 6 years at this point, but that's assuming that the cooler was properly used and installed and not too highly thermally abused. So let's get into some of the testing information and layouts and then talk about the rest. First, with the cooler incorrectly mounted, it's very likely that the customer will experience one of two things. One is that there could be poor thermal performance as air bubbles settle in the pump block, eventually leading to an RMA or replacement before it would actually be needed if used properly. The other one is an avenue where the cooler can get replaced for acoustic reasons. So as far as permeation goes, the first issue, this can also speed up if running suboptimally due to air bubbles accumulating in the pump or otherwise impeding water flow. And as for the acoustic issues, most of our commenters who've complained of pump whine or that water feature trickling noise have found that flipping the cooler the right way around resolves many of those issues. People who don't do this may end up prematurely replacing the part when it'd be fine if mounted more appropriately. Permeation rate increases with longer tubes, higher coolant temperature, and with thicker tubes, and is also highly dependent on the material used in the pump block and in the tubes, and we'll talk about that aspect after we get through the testing. Most loops are designed to run under 60 degrees water temperature, like the Asetek products, and keep in mind that you can run a 9900K at 95 degrees T-junction all day long and still be in the 30s for liquid temperature. So hitting 60 for the water temperature is very uncommon, but it becomes more likely as the improperly installed loops age. The plastics get soft at about 7 DC for Asetek products, where the clamping force will start to mushroom out the plastics when they are softened under those higher temperatures. Coolant pumps can operate about 5 degrees higher, and a hotter CPU or GPU will accelerate permeation, as will frequent thermal cycling or constant uptime under high load. If you rarely turn the system off and also have the radiator improperly mounted, the issues will compound and could lead to early cooler death, where it might survive otherwise if it were mounted properly to begin with. Let's go through the problems, and then we'll get back to the science of manufacturing these products. Our first experiment will demonstrate a common proper installation choice: top-mounted, tubes down. From a water circulation perspective, you'll basically never go wrong with a top mount with the tubes down. It's not always the coolest to run exhaust instead of intake, but at least the flow will be correct. In this orientation, the pump is below the radiator and the air will sit at the very top of the loop as it was designed. It won't get sucked into the tubes because flow isn't fast or violent enough in the inbound tanks to cause that. In our clip here, you can see where we change to this orientation that the inbound tank rapidly fills. while the outbound tank drains. The entirety of the air presence in the loop is now visible above the outbound tank, well above the barb, so our loop is running healthy. It could use some more water, but this could also easily run for a few years like this if under operating conditions that aren't abusive. In fact, to prove this point, this particular EVGA hybrid cooler is about 5 years old now, and it's had about 2 years of use before we stored it for a couple of years. When we drained this for this project of cutting it all open, it had about 100 milliliters of water in it, and that's pretty much what these ship with, plus or minus about 10 milliliters. But it was also mounted properly for its entire in-use life, and it wasn't abused thermally. Looking at the cold plate during this orientation, you can see the water is expelled from the pump by centrifugal force and maintains a high speed. The water then re-enters the outlet and goes back to the inlet tank. It'd typically go through microfins in this process, but those were removed for visibility. Remember what these clips look like as we progress through the others, because these ones represent how it all should look internally. Getting into the problem mounts then, air will always try to find its way to the top of the loop. Starting with the newest improper installation that we've seen spread far and wide with the NR200P, mounting a pump at the top of the loop is one of the quickest ways to cause noise, poor cooling performance, and potentially early replacement of the cooler. It's not always necessarily early death of the cooling product, because pumps like Acetex, for example, use magnetic levitation and therefore don't technically need a lubricant from the liquid to stay alive. But the damage can be caused elsewhere in the loop from running at temperatures that soften the plastic if you don't notice the air pooling in the pump. Keep in mind that a user's tolerance as well for high temperature will be lower due to reduced performance, so it's often assumed by the user that the pump died, even if it technically didn't. It might be fine and just need to be rotated to get the air bubble out, but from a user's perspective, this normally constitutes a failure and they'll just RMA it and call it dead. Tubes up, radiator down, and pump up top is what we're starting with. This means that the air bubbles will rise to the pump. In our side-by-side, you can see how a pump at the lowest point in the loop is going to behave when it compares to a pump at the top of the loop. There's high velocity of water entering when installed properly, while liquid doesn't quite reach the pump when it's mounted improperly. We didn't simulate much permeation here because you can see the entirety of the air bubble in the shot of the plate. In combination with manufacturing tolerance, running a cooler like this for a while could easily get you to the permeation levels equivalent to the liquid level tested. Even if yours is filled higher than this one, you're still going to run into some issues over time. It will cause endurance issues as it ages, and it will cause acoustic and thermal performance issues immediately, but especially acoustic issues. Air can get forced through the loop eventually as well, especially if you tap it, and it'll briefly get stuck at the top of the tanks before going back into the barbs. This air will then prevent proper flow if it's sitting between the tank and the barb, especially when it jams the outgoing tank. That said, for the most part, it'll just end up getting sucked back through the pump because the pump is at the highest point in the loop. Either one of these is bad. The former one prevents water from going up the tubes, but it's likely to be resolved shortly and on its own. The latter causes immediate issues, though, with pump whine, aging, and performance. As for the pump, you can see the yellow pump in the middle of the cold plate barely getting any water. The CPU will run hot while idle, but not hot enough to trip TJ Max. And it might trip TJ Max and throttle under load, but that's still a performance issue, and that's still something that a user would call dead. Worst case scenario, though, is that it's working just well enough. It's got just enough water going through there to keep the CPU under TJ Max, but not well enough to keep the water really properly circulating. In this instance, what happens is the plastics will begin to soften internally and deform, and over time, the pump will in fact be something you could call dead. Technically, it would still work, but the unit overall would no longer be functioning as designed. So that wouldn't be even a manufacturing flaw, it'd be a user flaw at that point from mounting it improperly. The next one is just sort of embarrassing, mostly because manufacturers do this all the time when showing off their cases and their coolers. NZXT, for example, is most guilty of this, and it's added embarrassment here of being the technical manufacturer of the coolers that it then shows installed incorrectly when marketing its cases. Thanks to manufacturers doing this because it looks pretty, and thanks to power supply shrouds requiring this configuration in many instances, people often mount their coolers tubes up. We always try to point them tubes down if possible, and if it doesn't fit that way, we mount it in the top of the case instead. In this one, we have to consider the location of the pump. The pump is likely to be about 1.5 to 2 inches below the tank, which is a good thing. We don't want the pump at the top of the loop anyway. If the pump is sufficiently below, the pump will be filled, but air bubbles will occasionally get sucked through the outlet tube and into the pump. That's because the air accumulates right next to the barbs. But ideally, we'd have it flipped so that the air accumulates in the other tank that isn't attached to the barbs in the tubes. The air bubbles that get pulled through will circulate. But this is the reason a lot of users complain about that water trickling or gurgling or bubbling noise. This is really more about the noise than anything else. In most instances, it does cause performance issues as well, but it's primarily a noise problem. So if you've complained about pump noise, check for this orientation. You can also get pump whine on some pumps when air is sucked through them, and that might last past the period of the air getting pulled through. In theory, a small amount of air won't get pulled through because it's not a high enough speed to get sucked into the tubes. But as the air cavity grows, once it gets down to where the barb actually connects to the tank, it can produce that bubbling and trickling noise that you sometimes hear as the air cycles through the loop. Finally, when front mounted and with the tubes down, this air bubble issue is no longer a problem. Ideally, the pump is still below the top of the loop because the other tank should now be at the top of the loop. If that's the case, we don't need to worry about air accumulating in the pump, because it won't, and we also don't need to worry about it getting pulled through the barbs, because that's not where the air is anymore. It's now at the top in the tank that's not connected to them. This top tank is actually designed in most radiators to capture air anyway, so the air will pool in the tank and sit in such a way that it's no longer a consideration in the loop. You won't experience any problems after the first few minutes of runtime, where the bubbles might shuffle around a bit as the loop is first powered on, but those first few minutes you'll hear it. After that though, things should smooth out, and the only thing you have to worry about is long-term permeation if you're abusing the cooler thermally, and that might still be a few years from now. There's one huge reminder for this orientation though. Do not mount the pump in such a way that it's at the top of the loop with the barbs at the bottom, because then it hasn't fixed anything. If you intentionally position your radiator lower on the front panel for some reason rather than higher, it's possible that the pump ends up at the top of the loop, at which point we're dealing with all the same concerns as we showed earlier when the pump is located at the top. Now that we've shown all of this, it's worth expanding on some of the science behind the cooler manufacturing. So tubing material, it's commonly FEP, EPDM, or a Teflon, or PTFE. EPDM is ethylene propylene diene monomer material and basically a rubber. There's also PTFE, which is a Teflon lined tube. You typically see it in a product like this, like Cooler Masters, where you can identify it usually by a corrugated tube rather than a rubber one. There's a Teflon lining inside of this, and that helps with preventing permeation. It's one of the best approaches to it actually, but there's a significant downside, which is that if you bend these tubes sufficiently, you can crack the Teflon lining, and that means that it will actually permeate much worse. Performance goes down in general, and it's a flaw of that particular material that weighs against its upside for some people. As for FEP, that's not as common anymore, but that's fluorinated ethylene propylene. Acetec provided Gamers Nexus the following information on its material choices. Quote, the rubber that we use is a special EPDM mix. In the mix is typically IIR, or isobutylene isoprene, and EPDM. The permeation rate of this material is greatly dependent on the mix between the IIR and EPDM, but also the internal mix of the EPDM, or how much flame inhibitor there is in it, etc. As such, EPDM can vary greatly in its permeability, and supplier-customer relationships are very important, as it ensures the expected quality levels and permeation rates, which for obvious reasons is critical in AIOs. Our R&D and quality department referred to the manufacturers of EPDM typically safeguarding their recipes as comparable in ways to Coca-Cola and its recipe. The mix that we use is Acetec only as an EPDM mix that is specifically designed to deliver the performance we're looking for to meet our rigid quality and control program. A Cooler Master uses FEP, EPDM, and the PTFE solutions for its tubing. According to testing that we received in documentation from one of the suppliers off record, FEP evaporation rate is about 0.001 to 0.002 grams per day under ideal operating conditions. This would accelerate if you're in suboptimal conditions. Further, it noted that EPDM has an evaporation rate of about 0.004 to 0.007 grams per day in its testing under ideal conditions. Anything featuring acrylic or transparent plastics will undergo significantly worse and accelerated evaporation and permeation over time. And most chambers use a PPS and glass fiber to minimize the liquid absorption, but those that don't may end up in a situation where their plastic is less heat resistant and can mushroom under the tension of the cooler. When we asked around, 2 of the cooling suppliers told us that coolers operating with a liquid temperature of about 20 degrees Celsius for their life can mostly be expected to live forever. Now that's from a permeation standpoint. Obviously the coolers can still die from other things like mechanical failures over time, but the liquid permeation is not going to reach dangerous levels under those conditions in that lifespan. Regarding waterfall effects internally, the flow rate is generally not enough that you end up with waterfall effects being a concern, but the liquid slows down once it hits the outbound tank in the cooler because it's already gone through all of the tubes within the radiator. So this is what can cause air bubbles to form and eventually be sucked through and back into the pump, as we showed in one of our experiments. We'll quote Arctic on this one as well because it provided the following guidance for clearing initial install pump noise issues. Quote, "Indeed, during shipping, the air is somewhat split all around the place. Once you plug the pump in the first time, it will for sure make noise. The noise will settle after minutes of running it. I would recommend even a few hours to have the final result. You might also help by stopping the pump a few seconds and restarting it. This is because due to centrifugal force, the air in the pump tends to stick to the pump axis and it will eventually go away, but stop-start cycles will help speed up that process." Anyway, that's assuming the cooler is actually mounted properly. So anyway, long story short, make sure you don't mount your liquid cooler like this, with the radiator at the bottom and the pump somewhere way up top, and really try to avoid mounting it like this. We understand that sometimes you don't have quite the tube length to mount it tubes down in the front and still reach the CPU cooler, but try your hardest. GPUs can get in the way, stuff like that, but it will ensure the best longevity of the device and also the lowest noise. Hopefully that helps answer all the questions in a definitive way so we don't have to approach this topic again. Share this video to make sure people stop installing their liquid coolers incorrectly, because a lot of people sadly end up wasting money on them and buying something else because they think that the cooler is bad when it was just installed in a way which is not optimal. So that's it for this one. If you want to support us directly, you can go to store.gamersnexus.net, where you can buy mod mats like the mediums, which are in stock and shipping now, similar to the one we worked on for this video, or you can pick up other things like the mouse mats. Subscribe for more. We'll see you all next time. One of the oldest debates in component selection for PC building is air cooling versus liquid cooling. Other than the obvious buyer advice that people seek, this is also an interesting topic because of one key thing. A really bad liquid cooler can cause catastrophic damage, which gets a whole lot of attention online, while a really bad air cooler will mostly just not work, but not actively harm other parts. For the most part, liquid coolers are safe for use and we have them in most of our test benches, but the times that a liquid cooler is bad, it's really bad and it gets a lot of attention. Reliability is one angle that we'll talk about today, but we'll also be focusing on thermal performance, time to steady state temperature, noise normalized performance with each cooler's own stock fans set to 35 dBA, and more. Our hope is that this will help you answer some questions before buying your next cooler for your PC build. Before that, this video is brought to you by Thermal Grizzly's Conductonaut Liquid Metal. Conductonaut is what we've used in all of our liquid metal and delid thermal tests, capable of dropping CPU thermals significantly when replacing the stock thermal interface. Lower CPU thermals don't just allow better overclocks, but also lower noise levels because the transfer efficiency is increased. The mix of gallium and indium makes for a thermal conductivity of 73 watts per meter Kelvin, outclassing traditional pastes significantly. Learn more at the link in the description below. So we're testing on different sized IHSs, different thermal loads from the CPUs. Our testing here won't be just one knock to a cooler versus a random liquid cooler. We're looking at a wide selection of both. We recently published a deep dive on our new thermal testing procedures for coolers. Air coolers, liquid coolers, doesn't matter. It's got a lot of really key points, so there's a separate piece on that if you want to learn about the methodology used for this content. It's all in there. There's also an article for it if you want the written version. Separately, this discussion altogether of is one better than the other, each of them is better than the other depending on the scenario. And we'll go through numbers to show which is best, in air quotes, for straight thermals, and we're going to talk about the practical side of things too, the reliability side of things. It's also, again, frustrating that people want such a bloodbath between liquid cooling and air cooling products, because it's a cooling product. And the level of emotion people seem to express in their angry internet comments about why someone else is an idiot for using a cooler that this particular person didn't use, it's insane. It doesn't make any sense. So most of the people who make those comments have no idea what they're talking about, and you should ignore them. So each of these things has legitimate use cases. We'll go over those. We're going to embark on proving which is better, in quotes, for thermal testing, but there's more to it than that. And a couple of key areas of consideration for this content will be as follows. 1, thermal performance. This is the primary talking point, primary evaluation. Point 2, time to soak or time to max temperature. This is a new test we've added. Ease of installation, the clearance of things like PCIe slots, big downside for large air coolers, RAM slots, and case compatibility. And that's a problem for both products, depending on what you're talking about. Longevity is another one, or points of failure and risk. At the end of this content, we're going to talk about the major forum arguing point of reliability and failure rates, because this is also something that's often discussed. The first chart is a new one. We haven't seen focus on this before, so we'll explain it briefly before putting the chart on the screen. We're calling this one time to max, representing the time required in seconds to reach steady state temperature on the CPU. To measure CPU temperatures in our later charts, we use a reading averaged across a couple hundred cells of data once the CPU has stopped climbing in temperature and has stabilized. This is known as steady state, or in our instance, the point at which the temperature is mostly stable and stops moving around. We allow about 23 to 30 minutes for this, depending on which CPU we're using. It's a fixed number for each CPU, and we found that this amount of time is sufficient for coolers of every size to reach steady state. One thing that isn't shown is how long it takes for those coolers to reach steady state. Here's the chart. This measurement is simple. We plot the second-to-second measurements across the entire test suite. Then we use spreadsheet formulas to determine the point at which steady state is reached. We have a lot more coolers than this tested for the later charts for thermal data, but here we're only looking at the new metric, so it's a bit more limited. The time is seconds taken, subtracting the known idle period prior to start. The Deepcool Assassin 3 and Noctua NHD15 are both large air coolers. They both required about 87 to 90 seconds to reach steady state temperatures, or their averaged peak that will be presented in later thermal charts. The 280mm Kraken X62 didn't reach its maximum peak temperature, which is also lower, mind you, until 260 seconds after the load started, or about 4.3 minutes. That's long enough that a bursted workload will calm down by then. And most workloads, like gaming, are bursted. They're not actually 100% CPU load constantly. They'll bounce between the CPU and the GPU. So you'd end up at a lower temperature than the air coolers for that work period, in the very least. The CLC360 takes longer than the X72 to heat up, specifically because of its higher overall temperature, resultant of poor static pressure from the fans. The amount of liquid gives the CLC360s, which the X72 also is, extra room to soak some of the excessive heat load that its fans, in the case of the EVGA product, have difficulty dissipating. But it's still, for EVGAs, a bad solution at this noise level of 35 dBA, noise normalized at 20 inches away. We'll talk about this more shortly. This is the biggest untold story of air versus liquid. The time to max temperature is significantly longer on liquid coolers to 240mm sizes and higher, as that liquid takes a while to warm up. So this is a potential upside, but it's one that most people won't really realize in their daily use. It's still important to point out, though. The test coming up will use the AMD R9 3950X CPU, a 16-core solution with a fairly high thermal density given the IHS size. The test bench has been configured to run at a fixed frequency and voltage, with vCore at 1.219 get and VSOC at 1.063 get. Power into the EPS 12-volt pins is about 200 watts for this workload, and other than power leakage, it's relatively unchanging. This one is noise normalized for 35 dBA at 20 inches distance in a room with a noise floor of about 26 dB. Anyone doing liquid versus air without normalizing for noise isn't really doing the test justice, since then the winner is just going to be whoever has the fastest, loudest fans, for the most part. We'll have those tests too, if you care, but you need this one to make sense of anything. The whole point of liquid cooling, after all, is that it can theoretically be run at a quieter noise level while maintaining similar performance to air. Let's get the chart on screen. Remember, this is noise normalized and it's using everyone's stock fans, so it's about as fair as it gets for a performance comparison. The big liquid coolers lead this chart, with the big air coolers not very distant. The Corsair A500 continues to act as a lesson that a cooler is only as good as its contact with the device being cooled. It falls behind at 61 degrees Celsius over ambient, or about 3 degrees worse than the Noctua NHD15 air cooler, and about 7 degrees worse than the NZXT Kraken X62 closed-loop liquid cooler at 280 millimeters for the radiator size. If you want to know more about why the A500 is as bad as it is, we have a review on it, but it primarily boils down to an unlevel cold plate that we previously demonstrated in this scatter plot. This plot from our A500 review shows the cold plate levelness. The A500 doesn't efficiently transfer heat at higher heat loads, but it blends into the background at lower heat loads. Overall, it's definitely worse out of the bigger air coolers tested, so this probably isn't the best representation, but it shows the low end. Back to the new chart, the EVGA CLC360 proves good only at higher noise levels, which we'll see later, but it struggles at these lower noise levels. Its fans don't have the static pressure required to overcome the radiator as competently as the Kraken X62. Partly because the CLC360 has more loss out of the sides of the frame, and 120 fans have to run faster anyway to compete with the 140s and pushing air through a radiator at lower speeds. The X72 also has a static pressure issue here, ultimately matching the X62 at 35 dBA. Note that these results reshuffle around a bit on the Intel HEDT platform later, where we raise the noise level to 40 dBA, allowing a higher RPM. The NHD15 is about 4 degrees Celsius worse than the X62, which we've long favored among liquid coolers. That'll get you a couple megahertz out of a Ryzen CPU, and it will afford you slightly more overvolting or overclocking headroom, but not enough for either to matter too much for daily users. As anyone with experience actually testing coolers can tell you, these results are expected. Large liquid coolers should perform better in an absolute and technical sense, and they do. The bigger note is that you could run the X62 still quieter and match the NHD15. If you normalized for thermals instead, you might be able to drop the X62 to 33 dBA instead of 35 and match the D15 at 35. We didn't try that explicitly, but that's about what these results say, and it's another takeaway for the differences in what temperature really means. It's not always performance, it can also be just lower noise. So then, no. Big air coolers are not thermally better than big liquid coolers when both are set to the same noise level on a 200 watt load. For pricing, the NHD15 is closer in price to the EVGA CLC280, but that's another Asetek unit that we've tested with high performance overall. It's one of the better ones actually for the price. The Kraken X62 is obviously way more expensive, and if you're just looking for a reasonable but not the best performance solution and you don't care about looks, and if you're not worried about RAM clearance, case side panel clearance, or the top PCIe slot, then the D15 is better value than the X62. They target different markets though, and that's half the point of this content. The X62 is clearly RGB infused and wants to go after that market, but it also fits in more ATX cases, even at 280 millimeters. And it won't cause clearance issues with the slots on the board, the RAM, or the PCIe slots. The D15 targets those who prefer old faithful performance and want to spend less. They're both good. It just depends on where you use it. In terms of strict thermal performance at an equal price, we would need to come down to a 240 CLC to check for that. And we can move to our older HEDT chart for that testing where we have dozens of liquid coolers for comparison. We've just run the D15 and the Assassin 3 for this one. We recently partitioned our Intel HEDT CPU cooler thermal charts into a soak chart, which measures across a power load dip that's intentional, and a peak thermal chart. Because we're testing air coolers versus liquid here, we'll only be using the steady state chart. The soak chart is only meant to help see how well the differently sized tanks handle the power load fluctuations. So this isn't useful here since we're trying to compare air and liquid, not just liquid to liquid. Normalized now to 40 dBA rather than 35 dBA and tested in a larger IHS from the Intel HEDT series, the Noctua NHD15 ends up roughly equivalent to a Corsair 240mm H100i Pro. That's what we expected. Thermal performance of the D15 when normalized for noise levels is about the same as a 240mm CLC of a similar price class. The H100i series is one of the oldest liquid coolers on the market, and it has models that come down to about $100. The EVGA CLC240, priced at $100, runs at 44 degrees versus the 47 degrees of the D15 on this particular bench. Remember that IHS size and die spacing will have a difference on thermals, so this won't translate to every platform out there in an exact linear fashion, but it should be a pretty similar hierarchy overall. We don't think the CLC240 is particularly worth it when considering the CLC280 is $12 more, but you can watch our review for that. As far as translating to other platforms, things that would matter and can change the performance stack would be monolithic dies versus multiple dies, like modern Ryzen or Threadripper versus monolithic Intel or Intel HEDT. The IHS size also matters, but ultimately the IHS size also is outmatched in terms of performance delta by the dip in the IHS, if it's concave or convex, and how the cold plate matches that. We'll talk about that in a moment though. The D15 ends up overall outclassed on this particular IHS, this thermal load, and this monolithic die, but it's still not bad. It's just not meeting 360 mil performance, unsurprisingly, and it's about 7 degrees away from peak 280 mil performance with the H159 Platinum at about 40 degrees, as is the X62. The X42 performance is nearby as well, but it leads into our next point about cooler design and what they're meant for. Cold plates are designed for different types of coolers. Asetek, for instance, designed its CLCs around Intel CPUs because their cold plates and pumps made the biggest strides before Ryzen came out. Asetek's older generations of cold plates were concave, which would better match the CPU IHS curvature, of the time anyway, and the two surfaces would fit together flushly once the mounting pressure was applied. Mounting pressure was considered in the building of these, and there was a known flex in the cold plate as a certain amount of pressure was applied. Asetek's larger cold plate also guaranteed every bit of larger HEDT IHSs would contact it, and there'd even be some spillover for extra soak. The microfins inside the cold plate are what really matter though, and these cover almost the entire area of the HEDT CPU IHS, at least non-Threadripper ones. That's a different story. It covers more than the die area of the CPU, and so they're once again matched well to certain cold plate designs. Gen 5 Asetek designs moved over to a flat surface and got rid of the tree-like concentric rings that older Gen 2 cold plates had. All of this is to say that you could optimize for any type of CPU you want as a manufacturer, and you're going to have some benefits there versus companies who prefer to generalize rather than specialize, or who specialized in something else. Neither is better or worse, but Asetek did build its original designs at the height of Intel CPU popularity, for HEDT in particular, and so we're not surprised to see the lead grow in this test. These liquid coolers are still in the lead on Ryzen, just less significantly, and that comes down to the IHS design and the die layout. Moving on to the 100% fan speed tests on the AMD R9 3950X, we now stop normalizing for noise and start allowing coolers to perform at full bore. For some, that's deafening, like the EVGA CLC360 and its 60.4 dBA noise measurement. It's the coolest by a long shot, about 4.5 degrees cooler than the already cool X62 at 51.5 dBA. The more acoustically reasonable X62 runs at 51 degrees Celsius over ambient, which has it 3 degrees better than the Assassin 3. The Assassin 3 measures at 54 degrees while at 46 dBA. The Noctua NHD15 comes out looking more balanced with its 44 dBA result of 55 degrees, but it's also technically at the bottom of the chart. The word technically is key here, because realistically, the difference between 55.2 degrees and 51.2 degrees is enough to account for a couple megahertz on a modern GPU or CPU, but not enough to create a meaningful performance change in your application. We'll move to the R7 3800X at 35 dBA now. Remember that we're changing everything with this. The core count drops from 16 to 8, the frequency changes from 4.2 to 4.3 gigahertz, and the voltage changes to 1.287 volts get. Remember also that our goal is to generate heat. The actual overclock is irrelevant, just the heat that it produces in watts, about 200 for the original testing and somewhere closer to 117, 120 to maybe 123 for this, depending on how much power leakage there is from the cooler. This CPU is running at a lower power but higher voltage across fewer cores. So the point is that you can't compare the results to the 3950X results. For this one, we've already collected some additional data with the Noctua NHU14S and the Noctua NHU12S, which are single tower 140 and 120 mil coolers, respectively. We talked about these in our A500 review if you want to learn more. The Kraken X72 and X62 remain about equal at this noise level, like previously, and that isn't a surprise. The X62 runs about 3 degrees cooler than the Assassin 3, 4 degrees cooler than the D15, and similar for the A500 to the D15. As we showed in our Corsair A500 review, this lower heat load benchmark is realistic for a lot of users, but it also doesn't exaggerate the difference between large coolers as well. That's amplified by the NHU14S performance, which is functionally equivalent to the larger air coolers tested here because of the limited power load going into the cooler. The larger coolers just aren't leveraged as much as in the 200-watt test. Still, the liquid coolers retain a technical lead, and the NHU12S shows that there is a point of fall off where you'd want something better. And even still, if you might upgrade later, overclock, or have some reason to need the higher-end coolers, it's important to at least know the numbers of what's better at the higher end. Finally, our last thermal chart looks at load temperature on the 3800X with fan set to max speed, again running at different noise levels, so this isn't the same as the 35 dBA test. The X62 and X72 lead the chart at about 50 degrees. The 72 seems to run at the lower end of the plus or minus 10% standard pump speed variation, whereas our X62 runs closer to the middle. So this is maybe part of the performance delta, but if we look at our HEDT test bench, which we're not going to put on the screen for this, but you can see it in our other reviews, the X72 runs at about 1 degree cooler at max speed, which is within variance of the 62. Either way, regardless of which bench we use, they're within error of each other and are functionally equivalent. The Assassin 3 large air cooler and NHD15, alongside the horridly inefficient and loud A500, are all about 2 to 3 degrees warmer at full speed. The NHD15 remains one of the most efficient operators at max fan speed, although with this lower power load, the NHU14S looks potentially better, depending on needs. It's not enough heat load to really push the large towers, but the liquid coolers still benefit from the reserve of water and the efficiency at which they move the heat away from the CPU. The question of liquid versus air has always been pretty simple, but people really seem to become cheerleaders for one or the other, and it's a bit of a weird mentality. Here's what it boils down to. Ultimately, in the strictest, most technical sense, roughly price for price, liquid is going to be, in large air quotes, better than air. But that doesn't mean it's better to buy. It just means that the temperature is going to be at least a couple degrees lower if you're noise normalized, maybe more if you're not noise normalized, if you look at the CLC 360, for example. So air coolers, even Noctua's air coolers, they're not magic. They can't beat the laws of physics. And a lot of people seem to think that they can because of bad testing. The reality is that they're good air coolers, but they're not going to be better than a good liquid cooler. There's really bad liquid coolers out there. There's really bad air coolers out there. But if you put good air cooler versus good liquid cooler, in the worst cases, they're going to be about equal. And in the best cases, for the liquid one, they're going to be a couple degrees different. But a couple of things here. We'd almost never recommend certain CLCs. A lot of the low-end Cooler Master ones have had issues with leak heat in general, and that's a matter of the CLC in particular, that specific design having a problem. We wouldn't typically recommend 120 mil CLCs. They're almost never a good deal. They're typically way overpriced for what you get. They're typically garbage performance, and you can get better for a small tower, like an NHU 14S or 12S in most instances. So 120s are mostly out. We would only really recommend lightly using those if you're doing some specific small form factor PC build that just can't fit something else, or you need more than a short tower. 140 mils fall in the same bucket for that. Both are contingent upon special cases. As for 240 and higher, once you account for getting an actually good product, because again, both exist, liquid cooling is going to lead, but it's primarily better in taking longer to heat up. This may or may not matter for you. If you don't know, then it probably doesn't matter for you. And it also just doesn't get as hot, but we're again talking a couple degrees different. So, and you might also be able to normalize for heat if you wanted, and then you're at 2 to 3 dBA different. So those are your main differences. It's kind of acoustic or thermal to very small amounts, and that's about it. The bigger differences are the most obvious ones. We'll start with air coolers. Large air coolers are going to be more restrictive for PCIe, slot clearance for the top slot, side panel clearance in terms of protruding out of the case, They're going to be more problematic with some of the memory that's on the market, like taller memory, and installation is typically a bit more annoyed with air coolers, especially on desktop platforms rather than HEDT, where everything's excellent to work with, and take a bit longer. So all that said, you typically only install a cooler once or once every few years when you build a new system. So installation is not really a huge point of consideration, but it's worth mentioning. There's a big misconception that liquid coolers have a high failure rate, which is also largely incorrect. Liquid cooler failure rate is universally pretty low, but it's made more bombastic by videos, including some of ours, covering the most catastrophic failures. For instance, nearly 100% of Enermax's LickTech 2 line for Threadripper will fail at some point. That's a high failure rate, but that's because of the company being cheap and not using the correct coolant. Asetek and Coolit, or CoolIT, supply most CLCs and also have units in server farms around the world. Their deployments number in the millions and include extreme environments like extreme cold or extreme heat. Liquid cooling is reliable and overall has a low failure rate, and most failures are not catastrophic, meaning they don't typically explode and leak in a system. The most common failure would be pump failure, but even that isn't that common. People just think it's common because of confirmation bias. Either they want to believe it's a higher failure rate because they have some bias, or they're exposed to more media, even including ours, talking about unit failures more than unit successes. And there's an obvious reason for that too. When we review a video card, it's a one-off instance. When we review a liquid cooler, it's a one-off instance. We'll only really revisit that video card in the counter example if there's some dramatic failure, because you don't typically, as a user or as someone in media, really go back to talk about something if it's been in the system and it's working fine. Because what do you do with that? That's not really content. Once people install the thing, they expect it to work. That's like what it should do. So you don't really want to give praise for that, because then it's just doing its job. It's doing what every product should do, which is continue to work under circumstances for which it was built. But when something catastrophically fails, you obviously want to condemn it or bring attention to it or get the problem fixed. So we don't make videos talking about how all of our test benches and all of our production systems have been using liquid coolers since basically forever. And we don't really talk about how some of the high-end units that we have in deployment on test benches haven't failed in 6 to 8 years. All that said, we get to the point in favor of air coolers. If you want something firmly reliable and with limited points of failure, an air cooler is obviously going to, well, in most instances, be that product. Liquid coolers, despite having lower failures than what is perceived, will still have higher failures than air coolers. There's a lot involved. It's not just a difference of there's a fan and a pump, so there's one more point of failure, the pump. It's a difference of there's a fan, there's a pump, there's liquid, there's permeation to consider, there's corrosion to consider if the manufacturer used the incorrect liquid, there's issues of the percentage of glycol if you're using it in a more extreme environment. There are a lot of things to consider with a liquid cooler that make an air cooler just a lot simpler. And that's a completely valid, very strong point in favor of air. All liquid coolers will eventually have their liquid permeate the tubes, even the really good ones. So at some point, typically, it used to be 5 years, now it's 6 or so, but it's a bit nebulous because we haven't hit that point for most of the good ones that are new yet. But it's an expected 6-year lifespan until you start having extreme permeation of the tubes with the liquid. And at that point, you either have to refill it or replace the loop or the cooler, depending on what you purchased. So this is another point in favor of air coolers. A fan might have a usable lifespan of 17,000 hours at the low end to maybe 40, 50,000 hours at the higher end. And in that instance, you could take an air cooler from one system to another for a decade. And as long as you have mounting hardware or can make mounting hardware, that cooler is still going to be good. Whereas the liquid cooler will at some point have some kind of mechanical failure within it, or will need maintenance to get the liquid back up to what it needs to be. So that's what it boils down to, is air coolers have one thing that needs to actively not suck, which is going to be the fan, and then one thing that needs to passively not suck, which is going to be the cold plate. And once you've gotten both of those things in order, you plug it in, does the fan turn on? Yes, no. Once those both check the box, yes, you're pretty much in business, and they're install and forget. As for us, we use liquid coolers in pretty much, actually in not pretty much, but every single production system we have here, and in every single test bench, actually. The CPU benches, The cooler benches obviously are different. The GPU benches, the only one we don't use a liquid cooler in is the case test bench, which is for other reasons. So we trust them enough for that. People have this idea that closed loop liquid is scary and prone to failure, but the reality is it's scary and prone to failure with untested units. And there's a reason Asetek and Coolit, the top two suppliers, are so commonly sourced, and it's because both of them have good failure rates. They're low. But there are very valid reasons to use air coolers, and we very much like the air coolers as well. I'd like to use one in my next personal system build because I don't want to ever mess with the system again. I'm going to build it and leave it alone for 8 years and run QuickBooks and Chrome. And so for that, an air cooler for me is great. Or if you just want something, again, that you don't ever have to think about, an air cooler is great. But at the same time, liquid coolers are technically thermally better if you are talking about a decent cooler versus a decent cooler at a similar price point, not the worst of the liquid coolers. I would say this, I think, in conclusion. Liquid coolers at the absolute low end are dangerous because they can cause harm to the system. They can break things. They can damage other components and potentially cost you a lot of money. Air coolers at the extreme low end will suck at their job, but they probably won't kill anything else as long as you realize they suck at their job in time. So once we're talking about the better stuff like we did in today's reviews, just buy whichever one you want. It doesn't matter as long as it meets the rest of the specs that you need. There's no firm better for everything. So that's it for this one. Thanks for watching. Subscribe for more of this type of content. Go to store.gamersnexus.net or patreon.com/gamersnexus if you'd like to support us directly in this type of extensive testing where we try to provide a really detailed end-all answer for something. We'll see you all next time. I think we might be live. Excellent connection. Thank you, YouTube. That's the kindest thing YouTube's ever said to me. Normally it says bad in all caps and red. This time it says excellent connection. I think we're live. Let me know if you can hear and see everything. And there's always comments in the archive that goes up that are like, yeah, we can hear you, Steve. So this is a live stream. There will be an archive going up later. It'll be unlisted at first, and then we'll make it public once it processes. YouTube takes a little bit to process the quality. Let me know if you can hear and see everything, and while I'm waiting for that feedback in chat, I'm going to tweet out that we are up and running. So we are live. OCing Linus's computer. Okay. I guess I should do @LinusTech. I'm going to check chat in 1 second. Tweet. Okay. It's chat saying. Chat saying a lot. Yes, they're saying yes, we can hear you. Okay, cool. All right, sounds good. So yeah, I'm gonna read all of this. Someone said I forgot I had this tab open. That must have been like, whoa, what was that? Yeah, it's been open for a little bit. We posted this right around when the contest was about to start, and then needed an hour to kind of reset our audio and setup and stuff. So we're back now. But yes, thank you for joining. We are going to be reading all the super chats. I see a couple coming in. I typically do them on about a 30 to 60 minute delay. Just want to let everyone know that now. But we will get through them all. We do tend to push them off for half an hour to an hour. That's because I'm normally working on stuff, trying to put on a show with the overclocking. So that does take some of the attention, obviously. And we just came over from Linus's stream. So if you were not familiar with what they had going on, it was really well done by Linus's team and everyone involved on the production crew. So, I mean, huge props to them for putting it together, pulling it off with everyone remote. Austin joined and Jay joined, along with Linus, of course, and it was a PC troubleshooting challenge. So lots of fun, but basically the way it worked was Linus and Austin were sort of judges or co-hosts, and they were spectating while Jay and I remotely tried to troubleshoot systems that I think, if I understand it correctly, were identical in their flaws. So we did that. I guess, I mean, the ending's probably going to be spoiled by people in chat by now, but I guess I won't say who won. You can watch their video if you want to see who won. It will probably be spoiled in chat, so if you don't want the spoiler, then close chat, I guess. But I have both trophies out here, so I'm not going to say who won. because it was a really fun competition and you'll enjoy watching it. Highly recommended. I actually need to watch it myself. I watched a little bit after we finished, and it looks really well produced. But these are the 2 trophies they sent out. I got to figure out what to do with the one that I didn't receive. We're probably going to do some sort of charity auction with it at some point. I just need to figure out the logistics of it. So keep an eye out for that. We'll announce it in a hardware news video. And then today what we're doing is we're going to overclock the system that Linus sent. I might clean it up a little bit too, because since it was a race, we were trying to see who could get the thing posting benchmark scores first. We had to meet the LTT benchmark scores where they, it's funny to see people saying there's like inverse spoilers now. So actually you shouldn't trust chat because about 50% of the comments are incorrect about who won. I'm not going to say which 50%, so you have to go watch it. But, so you shouldn't trust chat either, apparently. Anyway, yeah, so we had to race to get it assembled and benchmark it. And I just like Jay was too, I sort of scrambled to get it going and left it a mess. So we might clean up a little bit of that, but we'll overclock it too. I have 0 practice on this system. Normally, before a stream, I'll do a couple hours of prep work and try to at least learn about the motherboard, the CPU, and how they behave. I don't even know what BIOS they have on here, so we're going to see how it goes. No LN2 for this one. Normally we do liquid nitrogen streams. This one's going to be like a normal overclock. It is a 10700K, and I think it's 3200 megahertz memory. That's more or less the extent of what I checked out while working on the hardware. The system had all kinds of issues with it. I won't go through all of them because I don't want to spoil it, but one of the more interesting ones, I guess, was what was the most interesting one, probably? The most interesting one's a bit of a cliffhanger, so I'll keep that to myself. You'll see it in the video. But one of the more fun ones was that they had the fans flipped. So they were, for the radiator there, they were going opposite directions. But my strategy was to just unbuild it. And you kind of see a lot of the problems there. And I only did that because I knew it was sabotaged. If it were like a real customer PC, I'd probably do the other approach. Let's see if it boots still. I don't know if I even have everything plugged in, but we're just going to turn it on and see what happens. I have a light OC on there that I did for the competition. I didn't want to work with, I don't know, I didn't want to, I was basically trying to overclock my way through any potential problems that might have been there. So I threw a quick OC on there. We did like a 5.0, I think, was the final number, and kind of ran with that. I need to grab hardware info. I don't think they pre-installed it. This was all set up by Linus's team. So we're just going to grab hardware info really quick, and that'll set us up for the overclocking today. Again, huge thanks to Jay and Linus and Austin. It was a lot of fun to do the troubleshooting challenge. If you loosen this, it will work. A lot of fun to do, and Linus did a prize pool. So he did $3,000 to a charity for the winner, and then he did a $1,000 for the winner. And this is kind of hard to talk about this stuff without spoiling it. The winner gave that money away to the charity as well, and then we've got an extra thing going on. You'll see it in the bottom left of the stream, where Eden Reforestation Projects is a group that we have worked with in the past. They do really good work with reforesting areas. Obviously, they acquire or get access to land, replant the trees, employ people who are in extreme poverty to do the planting and to maintain the forest that they plant. So anyway, we're giving 10% of the total store revenue, gross revenue from the store, 10% of it, through August 20th to them. And then if you would prefer to donate directly, that is completely fine with me, because my goal is to support their work. So if you want to donate directly, go for it. We're going to do a $1,500 match donation as well, just for whatever our viewers do. Actually, I need to put their link in the description now that I think about it. So we got the system booted, and I'm going to check the super chats in a second here. Give me a second to figure out how to use the YouTube interface to, oh, there it is, update the stream. Eden Reforestation Projects. I'm just going to put their link in there if you wanted to go directly. But if you want to support through the store, then obviously that's a great way to do it too. Find them here. Okay. Save. All right. Hopefully that doesn't break the stream. Someone says Intel won. I mean, 50,000 viewers. Yeah, they had crazy viewership. Like, job well done, Linus. Congrats on that. I think they were at 65 concurrent peak. That might have counted Twitch and stuff too. I'm not sure, but crazy. Okay, so yeah, I see the super chats. Definitely appreciate it. Give me a second to get to those. I want to look at some basics to get the show going. I'm actually going to change this background too, so that it's a little bit easier to see things. Can we just do? Okay, all right. Thanks. Not activated Windows. Where's the fill bucket, Andrew? Oh, there it is. Background. See the high-tech way we work around the Windows registration limitations. There we go. Now we can see stuff. Okay, so I'm going to set the resolution a bit lower as well. It is 1440. We're just going to go down to 1080 so that it's easier to show it. Do we need to get this off the pole? Okay, it's not in your way. If it is, feel free to remove it. So anyway, here's hardware info. One thing I didn't check in the troubleshooting stream was what were the Windows power settings, and it looks like they're not actually set to high performance. No, but that ended up not mattering, so that's okay. But I'm gonna set it to high performance. What that's gonna do is stop screwing with the clock so much, so now you can see that it's reading 5,000 across the board. This was the 5-second OC. I mean, if you ever have thought that you have to spend hours doing an OC, that stream was proof that you really don't. It's just not going to be efficient. Like, I typed in just some random vCore and let it go. I think it did 1.38 LLC level 4, and we're going to tune that now. Let's see. Was the chassis an InWin 303? No, I think this is called the 805. I made some choice comments about what I think about this case in the stream. Mainly, where does the air come from? And the answer is nobody knows. Let me get. I'm just going to get the panel off so we can work on this. How did you provide a video feed to Linus Tech Tips? I'd like to know. It was so interesting. I've never done a stream like that before. So I mean, I'm not. They can talk about it if they want to talk about their methods, but the short of it is that I had a really crazy setup because I had a piece in my ear so I could hear them on Discord chat, which is connected to my phone, and then the laptop was on the table. My laptop was on the table actually just for the mic. So it was just receiving my audio when I talked to Linus, but then they were taking my audio from the lav for the actual stream. So that's the workaround I had to do to make it work, and it was insane. Not a good way to do it, but yeah, it worked, so. Okay. So let me check some of the super chats, and then we'll get going here. Viewer activity. Tom Kavulik, good to see you back. I have definitely seen your name in here a few times now, so always happy to see regulars. We recognize the names. $50, wow, thank you. Says Steve number 1. Sir myself sent Canadian 666, always an admirable donation. Pleasing the, oh, actually, it says Iron Maiden right there. I was about to say pleasing Bruce Dickinson with that. Congrats on the win, Steve. Uh-oh, well, there you go. That was the super chat. That spoils it, I guess. Sorry. At least, whatever. Iron Maiden trivia quiz number 2 to get times 10 again. Oh, man. How did Bruce Dickinson intro Rime of the Ancient Mariner in 1984? I haven't listened to that song in like a decade. I'm completely blank on it. Sorry. I'm normally pretty good with them, but I was mostly listening to like sort of Fear of the Dark type era, and Rime of the Ancient Mariner I haven't heard in so long. Snack Juice, Canadian $5, thank you. Now that it's August, can you get Roman to send my wife that O11 Mini? I don't know that any person has the power to get Roman to ship anything. Speaking of which, this stream is brought to you by Thermal Grizzly. It's somewhere around here. They're linked in the description below. Fortunately, Roman is not the shipping person for Thermal Grizzly, but this is what we used in the stream, actually. I did kind of a funny clip in Linus's tech support challenge. Linus came in and was like telling jokes about my thermal paste application, and then when we did a second application later, I just dumped like the whole tube on the system. So that's what's in there now, and it seems to be running. I'll get back to super chats in a second. Right now we have, let me get these out of the way. We have XMP applied, and let's see. All I did was XMP, I typed in 50 for all core. If you didn't catch it in the stream, how's the shot of the monitor? No glare? Oh, not too bad, I guess.
I think it's that part.
Okay. What if we do that?
That's good.
All right. So if you missed it, what I did was just some basic Digit Plus VRM stuff. So this is an ASUS subsection of Extreme Tweaker. We're not doing extreme overclocking today, so this is stuff you could do at home. I'm not saying this is a guide, but if you want some basics of where to look, this will give you some pointers. So I set the current capability to 140%, so we weren't going to be current limited, and we ignored the VRM switching frequency. You can tune this. Sometimes it helps, but I don't have a lot of experience with it. BuildZoid and Hardware Numbers really know that stuff well. VRM spread spectrum we disabled. Let's see, I set CPU power thermal control to 145 for VRM, but that just was totally irrelevant, didn't matter. The reason I did this, if anyone was wondering, one of the things I suspected that Linus's team might have done, but they actually didn't, was I was suspecting that maybe they didn't put the VRM heatsink back on properly as like a sabotage. But so what I did was I just blasted the amount of, the temperature limit for the MOSFETs, because the benchmarks are short, so I knew it wouldn't matter. But anyway, that's why I set that, but ends up not being important. And then the rest of this I left alone for the stream. Let's see. Oh, I did a cache ratio, which actually does help a lot. This helped in the Heaven score. So 47 I set. We've gotten up to like 50 on some CPUs, but I've never pre-tested this one. We did 138 for vCore with an LLC of 4 because vDroop helps a bit. 1.4 for the memory just to make sure I didn't have any weird issues. And that was pretty much it. So let's go ahead and run this as a baseline. I've got the fan set to max speed right now. The case has its panels off, but it is still pretty restricted on airflow, so there's not a great solution working with the case. But okay. I need to catch up on some of the chats and stuff. Let's see, what was I working on? Oh yeah, that's right. We did some other interesting tricks too in the stream. You'll see me put tape on the CPU, the back of the socket. So I threw that on there to hold the back plate in place, because I knew my strategy was gonna be to unbuild the system and redo it. So that actually helped a lot, because if it's not like an HEDT platform, it takes me forever to get the back plate oriented. Okay, so let's, Heaven took forever to run last time. I'm probably gonna try and avoid that for the most part. Let's just run an R20, because I don't actually know where our score was. And one thing I didn't do during the stream, because I didn't care, because it didn't matter for the competition, was I didn't check the temperatures. So I'd be really curious to see how close to the edge I was pushing it or not. So this run is not going to have a valid score because I'm running hardware info, but it will give us some temperature numbers we can work from. If you're watching this, you don't really do much overclocking, so this is a good stream to watch, because you'll see some of the basics without doing liquid nitrogen stuff that we often do. So if you want to OC your own CPU, we have a whole like hour-long thing on Ryzen, but the basics aren't too different. What I typically do is I start by doing some research on where do I expect the CPU to really fall. So like with Intel, with modern Intel, we know that they typically max out between 5.0 and 5.3. And we're going to try for 5.3 today. I might try for 5.4, but with this cooler, I don't know if that's happening in this case too. So I'll try a number that seems to be about the average online, or maybe 100 megahertz below that. And then I'll set just a 1.4 vCore for both, for Intel and AMD. And that's on the high side, but my goal is to figure out where's the frequency, where does it stop being stable at that voltage, and then I start bringing it down the voltage slowly. And then once it's no longer stable, we've found our sort of combination of volt frequency limits, and then you just adjust. Do you want lower voltage? And bring down the frequency, or do you want to push it a little more and run hotter? So anyway, let's see if this is important. No, it is not. Okay, so 5196 for baseline. I think we have, I saw someone say hyperthreading was disabled, but I actually never noticed because I cleared CMOS. So we're good here. This is a 10700K, and I think what I'm going to do, so Linus has given this system away that we're working on right now to a winner, and where's the spare parts? So he's given it away to a winner. We actually have an extra CPU as well that he sent for the troubleshooting challenge, and I don't think there's anything wrong with it, but I'll check. And so before anyone's like concerned about this being overclocked, one, it's not going to shorten the lifespan because we're not running it under LN2. But two, if anyone's worried about that, I'll probably just put the spare in that they sent because it won't have been used on the stream at all, as long as it works. Okay, so 5196, let's run this again without any background tasks blowing it up. But temperatures, you should never look at max temperature as a column for what's the temperature of your CPU. If you're doing like a benchmark, like you're testing a cooler, you should log things and measure it more accurately. But for purposes of what we're doing right now, this is fine. So we actually peaked. We're under 80 for the most part, and the core-to-core deltas here are pretty low. One of the things you want to look for with overclocking is what's your peak core-to-core delta, and I'm seeing about a 10-degree max. So our coolest core is 10 degrees cooler than our hottest core, and what this tells us is the hottest core is going to be the one that, actually these two here, these will be the ones that dictate our maximum clock because, well, thermally anyway, if we're allowing a TJ max, thermally those will be our limiters. And so ways you can fix this, typically you don't have many. D-lid is one of them, but this is soldered. We're certainly not going to do that on this for someone who's winning the system. It becomes maintenance. But you could D-lid and do liquid metal, and that would help. And sponsor of the stream sells that too, linked in the description below. But more commonly, just try your best to work around it, unfortunately. Or you could lap the die too. That's another really good solution. So yeah, that looks fine. We're good there. I want to check these as well. I'm going to go through some basics today because we have a good amount of viewers who haven't, I don't think, tuned into our OC streams before, so maybe this will help you if you want to overclock your own system. These are good numbers to look at in Hardware Info. Hardware Info 64 is free. It's extremely good. So this is just yes, no. It's a binary of are you hitting limits, and we're not. This is another yes, no, are you hitting limits? So what we're going to look for is yeses, and we see one right there, which is IA max turbo limit. But this doesn't matter because we've manually overridden that, so it actually is irrelevant. But yeah, that's a really good tool for figuring out if you need to go into BIOS and disable certain power limits and things like that. Let me get back to chat. What's chat saying? Linus is in here. Linus says, we have fun days every day. He's replying to someone. Linus, say anything else? I see Bearded Hardware also. Good to see Bearded Hardware. We're going to do some of the super chats in a second. I'm just checking on the normal chat. Oh, Linus tagged me. He said, fun fact, Nicholas from our team had to redo almost everything because we were too savage with the things we did to the systems. Linus, if you're still in chat, I would love to know some examples, assuming you're not saving them for later, of what were the things that you guys thought were just like too far, like we've gone too far. Because I think I'd love to think about if I would have been able to solve it. A couple things I was expecting. I was really expecting them to screw with the BIOS on something. So either VBIOS or the video card. I was kind of expecting like you could load a bad BIOS that locks it to a lower frequency, and that would have been really tricky. I'm not sure I would have caught that in reality. Or like motherboard, you could screw with the BIOS, but they didn't do either of those. They did have really tricky stuff in there though, and I'm not gonna spoil those since I already accidentally read someone's super chat and spoiled the winner. So, what are the specs of the PC? You should honestly ask Linus in the chat. They built it. 10700K. That's a Maximus 12 Hero. This Gigabyte cooler I haven't reviewed, but it's actually running really well. I don't know if it's comparatively good, but just, I mean, we have benchmarks for that. We haven't run this one. but that's the cooler. Power supply is a Seasonic 1000 watt, I think. And they have some, I think they have a Sabrent M.2 in there, and they have a Corsair Force 2.5. I'm not sure on the rest, but that's what I can see from here. Looks like 3200 G skill. One thing I will say is I really wanted to flip this, because you should absolutely have your tubes oriented down for noise reasons. But, you know, for a competition, it was like, well, it's already on there. I don't have time to flip it, so we just went with that. Okay, I haven't seen a response from Linus, so I don't know if he left the chat or if he hasn't heard me, but let me take a couple of super chats and then we'll get over to this. It's at 5.0 right now, very quick OC. We'll do better though. Let's see. Bazinga X, you once again proved that you are the true tech Jesus. I'm not sure that there was like, I don't, like that kind of implies that there's multiple people called that. So I don't know who the others would be, but I'd very much appreciate it if they'd stop infringing on our naming that the community has provided. Lamette Productions. That was more fun than I've had in a live stream. What a great stream. Yes, Linus's team, like I said, insanely good production quality on that stream. It's really impressive. Okay. All right, let's do some stuff. So 5250 points is where we were for Cinebench R15 without anything running in the background. We have a lot of thermal headroom to work with. We've got about 20 degrees to work with right now. So first thing I'm going to do is increase the clocks without increasing the voltage. We'll leave it 1.38. And then I will, if I need to, if we get a blue screen, I'll increase the voltage from there. And while this is booting, I'll shout out the store. So like I said, we are doing a share of our store revenue, gross revenue, 10% of the store revenue through August 20th to Eden Reforestation Projects. If you'd like to buy something from the store, which you should, because if you want a mod mat or a mouse mat, we're going to be very low on inventory soon, then we'll give 10% of the revenue from those to Eden Reforestation Projects. We've worked with them in an official capacity before. They were great to work with. And if you want to give to them directly too, I've posted a link below, and we'll do up to $1,500 match with the community. Okay, so let's leave all this alone. And I'm going to leave, I want to come back to cash ratio. It actually matters a lot, not as much for Cinebench as other things, but it does matter. Let's just do a 51. And this is the one that blue screened in the stream, and it caused a lot of suspense for a second. Yeah, so the mouse mats right here, the mouse mats we have actually sold through about half of the supply that's coming in, and we ordered a lot. Like it's the biggest order I've ever done. We've already sold through half. So these are on back order. They sold out in 2 days when we originally listed it. It is a $30 MSRP wireframe mouse mat, so it's got PC component designs. We have the heatsink SSD with all the flash on it, motherboard with memory, video card with VRM, full VRM and all that stuff. You can download more RAM. So it's a wide desk mat. It's on store.gamersnexus.net. And if you back order it, they are shipping end of August, along with the large mod mats, which I'm working on underneath this. This one's a very well-used mod mat. It's done its job well of working as a build service. But mod mats are actually in much lower supply. I thought we were ahead of it, and we were not. So if you do want a mod mat, or we haven't been able to keep the mod mats in stock for more than like a week ever in history. So maybe once, maybe like when we first launched. Actually, I don't think you, maybe then, but yeah, you can grab one on the store. Those are shipping also end of August. That's when they arrive. But if you back order it, then you're guaranteed to get it. Okay, let's run it. So 51, we're just gonna see if it blue screens. I'm expecting maybe, because it did in the stream with Linus. And what we're doing is a 1.38. Oh, okay. I will avoid standing behind the computer. I'm being told that wind is blowing into the mic. Actually, I can probably just cut that fan. Let's just kill the fan, because it's open air right now anyway. So all this is just going to come out here. Okay. What is a safe vCore for a 10600K 24/7? So, this question I always struggle to answer, because there's not really just like a fixed, there you go, crashed, so it's not stable. Not really just a fixed answer. I'm gonna do R15 and see if that works before we reboot and up the voltage. So I'm pretty comfortable in like the 1.3s. Like 1.3 to 1.4 range is where I feel pretty comfortable for a 24/7. I'm not saying that's like guaranteed, but it's 14 nanometer. Intel's process, this 14 nanometer silicon's been out so long now, there's a ton of data on it. You're pretty good at like 1.4 even. So for me, personally speaking, 1.3 to 1.4, I'm fine at 1.4. It doesn't really bother me. I'm not worried about degradation of the CPU at that voltage, but I'm not guaranteeing it will happen. That said, the data does sort of support that. That's fine. Just be careful of your LLC. You don't want to run it hard, because then you're going to be over that number. So 2204, R15 did pass, but R20 is not stable. It is a longer benchmark, and that's going to cause problems for us. So I need to up the voltage a bit to make it through R20. Okay. Let's see what, oh yeah, thanks. Someone asked the GPU. It is a 2070 Super, I think is what they sent us. So I'll do that too. We might as well overclock the GPU. We haven't done that in a while. It's pretty fun. It's been a long time since I've done a GPU OC on stream. So we want to do 51. So we'll get to that too. Let's start with the CPU and just find where we start hitting our max temperature, where we can't push any further. Linus is so big now, he's actually outsourcing he's outsourcing actual work to smaller YouTubers. Hey man, Linus told me when I went to LTX the first time, he said something about, we were just talking like off-site, and he said something about, we're in a spot now where I really want to leverage our ability to bring people together. And I thought that made a lot of sense, because like the show's, it's a lot of pressure he and the team's under to put on something like LTX. And they do a great job. So yeah, absolutely, he's outsourcing some of the actual work to smaller YouTubers, and you know what, he's doing a good job. Okay, let's see if it survives. I don't know what this loading thing is. That was popping up so this popped up in Linus's stream, and I immediately thought they loaded fake malware on it and started looking for it. Only thing I found that was malware was the ASUS utility. I should caveat that was a joke that's known as humor before ASUS sends a cease and desist or something. But I think it might be RGB software. I think it's that Oris stuff. Let's see if it survives this time. Looking forward to the GPU OC. Those are always so much fun. Do you have an in-depth article about the basics of overclocking, more specifically what voltage settings or other settings? So the best thing I can recommend that we've done recently is go to our YouTube channel, and it should be within the first couple scrolls. You'll find a video, a live stream archive we did. It's probably about 2 hours, 2.5, but half of that was super chats, which I'm going to get to these in a minute too. So it's not as long as it looks for the overclocking segment for the how-to guide. And that we go through like every setting that you'll need for basics on Ryzen. And a lot of that applies to Intel. It's not quite the same names, but it's the same principles. A lot of the settings are actually the same as well, so that's what I'd recommend. Okay, let me do some of the super chats for a second. Doggy's Tube, $5. Can you add coolant to Arctic Liquid Freezer 2? Yes, you can add coolant to it. I don't have one within reach right now, but I mean, like, you'd have to disassemble it. So that's not like the most fun thing to do, but it's not that difficult. So yeah, you could add coolant if it is like low for some reason. Bazinga X, $5, says Bitwit won. That's it. Bazinga X has given away the end of the competition. Linus's PC troubleshooting competition, where Jay and I battled each other to try and fix this computer. It was actually won by Bitwit. Mustangs by Matt, $20. Thank you. Good to see you back, Matt. The troubleshooting challenge was a lot of fun. I did the 16 terabyte hard drive tests, he says in quotes, and it didn't end well for Seagate. Sending you a package with the drives and a couple of gifts. Send an email. Yes, so the Mustangs by Matt shoots hard drives with weapons. And it's like data destruction. I think he did it for clients at one point. It definitely destroys the data. So there's no coming back from that for the hard drive. We actually have a few of the ones he's shot in the back of the set. We're still not sure if it was a threat or if it was just a cool prop, but it's cool back there. Okay, so 5346. is our score at 51. That is an improvement of, I think it was about 100 points. I should be typing some of these down, but let's write that down. So I think we're at like 50. Someone can tell me in chat. It was like 5250 or 5215 originally at 5.0. And then we're at 5346, 5.1. I strongly recommend writing down the settings you use for each pass as you test it, because later when stuff starts breaking, you're going to want to go like, okay, where was it working? And then you reset back to those. So I would write down the voltage, LLC, all that stuff, and then whenever you change it, make a note in like a spreadsheet or something. So yeah, that's pretty good. Happy with that. I really want to get the CPU to the max. I don't have Asus Turbo V-Core on here, so we're gonna have to go through BIOS for the overclocking. And this is, if you're just tuning in, this is exactly how Linus sent the system to us. We're just overclocking it now. So we maybe get a shot in the computer here. Let's see if that's bright enough, hopefully. Hang on 1 second, let me try and get this to stay. I'll just hold it. So yeah, this is the machine they sent us. We had to do a troubleshooting challenge, and I'm not gonna go through all the individual things that we fixed, but needless to say, Linus's team put up a really strong fight. They really screwed with this thing, and lots of cool stuff to fix. But end of the day, we got it running. This Gigabyte cooler is doing better than I thought it would for the overclocks, and I threw a quick OC on the stream just to brute force my way past issues, and now we're going to expand that. So I'm trying 52 for the multiplier now. Let's get this out of the way and see if it'll run at 52. Feel free to move the light if you need to. Let me read a couple of super chats. I need to check the normal chat too. Big Al 268, good to see you back. Big Al sent $50. Says something for the winner, and then says Cat Angels. Yeah, it's so hard to like avoid spoiling things, but that part's already been spoiled in the stream. I'm just trying not to like repeatedly do so since people join and leave. But yes, they should be very happy. And thank you, Big Al. Jackson Tint, $5. Did I see an LTT store water bottle in the background at merch collab with Linus when? You have the two best merch stores of the PC tech community. Well, thank you. I appreciate that. We work really hard on it. The mod mats and the mouse mats are probably my top two things we've made. The mod mat, I think I hold the mod mat the closest because it was the first real, like, fully unique product we did. But yes, you do. At the end of Linus's stream, I decided to give him a shout out too. I filled his water bottle with, I think this is their new like 40 or whatever. I filled it with, you're gonna see Linus walking around with like a brown paper bag over this in downtown Vancouver. I filled it with liquid nitrogen and I poured that into one of the trophies. And then I immediately dumped it out of the trophy because I was worried that the plastic would explode. So you'll see that in their stream at the end of it. All right, let's do R20 run again. So we're trying 52 for the multiplier. We're just gonna push as high as we can until we hit a thermal limit. It's really nice to work with and like quote unquote actual computer for once instead of LN2, because I've got hard limits where I'm not gonna be able to get past what the cooler can do. So once we find that, we'll get to do the GPU again. I'm really looking forward to that because it's been like probably over a year since I've overclocked the GPU on stream. And we're not gonna be able to go too crazy, but we'll do a bit. Get some more super chats. Wishbone, good to see you back. Oh, yep, okay, there it is. That's the comment I was expecting. Wishbone says, Linus didn't make you guys test run Beetle Adventure Racing on LN2. Shame on you, Linus. Yes, Wishbone for several years now has been requesting that we test Beetle Adventure Racing. And at some point I should probably do it just for Wishbone's sake. For the longest time, I thought it was probably like a meme game about Beatles the Bug, and then I realized it was a Volkswagen game, I think on N64. So that's we definitely, like those of you who are regulars in the chat, definitely recognize the messages. We've seen them a lot, some of these. I appreciate the ongoing persistence from Wishbone. Patrice X, I think, is how this is pronounced. $5. Greeting from Brazil and congrats for the win. It was a lot of fun. Oh, we spoiled that again, but yes, I've decided to just I've decided to stop trying to prevent saying that, I guess, and just not give away all of the challenges. So that's the thing I've reverted to, not spoiling, was all the challenges. But yeah, thanks again. It was a really fun stream. Very clever idea and good way for them to try and make do with the situation since they had to cancel LTX, obviously due to international travel issues. So looking forward to seeing what they do next. Martin Parker, $10. Hey, did you see the video where SK Hynix tried to pay level 1 tech for an SSD review? Wendell was not impressed. I did not, but anyone trying to pay Wendell for a review, I think, is in for quite a surprise, because Wendell's got about the same requirements and standards we do, and he's also next level technical on a lot of the stuff that they're probably asking for. So definitely they were in for a surprise. I'll go watch it though. I didn't see it, but that sounds fun. Okay, let's try a 1.42 for vCore, and then what I'm going to do is check hardware info this time and see if it's crashing from thermals or from stability. What's the name of the case? It is an Inwin, I think, 805, and I would not recommend this case. It is one of the worst designed I've seen for thermals in a long time. Actually, that's not true. We've reviewed a lot of bad cases. It's up there in the top 5 of worst thermal design. But that said, it's pretty, and they did some cool stuff with the lights. I don't know I think I disconnected them, but there's a bunch of lights in here that are actually super cool. I just wish they would get rid of this glass panel. It'd be really cool without the glass panel, and it would probably, if they punched out better holes, cool reasonably well, while also still having the look they want. I keep feeling kind of bad for whoever's going to win this computer, because I'm trashing the case, but also they're going to win a very expensive computer, so I don't feel that bad. I guess it's still objectively good. So okay, so this time we're going to run it again. If it crashes, we're going to start to find out now, vCore or thermals. What do you need, Andrew? Okay, just checking for where the robots are. Just let chat try to figure that one out. Okay, so we're gonna need some more vCore, I think. So this setup, if you're doing overclocking stuff and you're planning to really work on it, try and crank some numbers, I'd recommend doing it on a test bench. I had it on one during the stream. Oops, I don't need that. I had it on this thing during the stream, and it just helps you kind of get good access to everything, all the buttons on the board. So I've got the panel open, that way I can just hit the start reset button. Okay, so let's go for vCore. Bit higher still. Let's just punch in 1.4 and give that a go. So we're stable 5.1, we'll see 5.2. I don't think this will matter, but we can see the chat in the reflection of the case occasionally, and Andrew's reflection. Hi, Andrew, they said. Andrew says, yeah. I don't know, should I rotate it? I guess it doesn't really matter for any particular reason, but that's probably more interesting to look at anyway. Until I need to hit power buttons. Where is it? Is this it? I think I can reach the power button from here. Yeah, that's it. Okay. Let's see. What else people saying? Martin Parker, $10. Oh, I got that one. Sorry. Jean-Paul Pittman, $10. Thank you. Cats are the real winners today. Thank you, Steve. Meow, meow. The Ozum, $5. Hi, Steve. Hi. Hope I said your name somewhat accurately. Kristen Langer, 125 PHP. Hey, Steve, check out Jay's latest tweet. Request to roast that case in 10 words or less. / Jay's 2 cents. What is it? Hey Gamers Nexus, look what you made me do. It's a video. I can't like listen to it right now. What is it? I'll watch it. It's a 45-second clip from Jay. I don't have audio on this computer, but I will watch it. He did, yeah, Jay also donated in that stream, and then we gave the prize money, and then Linus gave money, so I think that's what he's talking about in there, but I'm not sure. I have to watch his video. Definitely a huge shout out to Jay, though. Was there a question in that super chat? Oh, request to roast the case in 10 words or less, or fewer. 10 words. I feel like I'm writing a haiku. Was it 575? 10 words. Terrible airflow. Bulging glass. It's not enough cable management room, in other words. Plasticky appendages we're going to go with for the feet on the case. I'm going to stop there. I'm going to leave myself the 4 extra words. I think I've done a good job. That's how we review cases going forward. It's going to be the GN intro and ad and then 10 words, and then it'll be the outro. Okay, so I need to run hardware info. We don't know if it's voltage thing or temperature yet, but if I get this open and look at temperature while it runs, I will know immediately.